Well, hi everyone. This is Carmen Vertullo with the Fastener Training Minute coming to you from the Fastener Training Institute and AIM Testing Laboratory in beautiful El Cajon, California. I've had an issue come up about 3 times this past year with some clients, and this last time it made me think perhaps it's something worth talking about on the Fastener Training Minute. The issue has to do with dimensional inspection of nuts, hex nuts in particular, and hex flange nuts in more particular. Now, we know that there are relatively common things we have to do to inspect the nut. We have across the flats, across the corners, height. We have the threads, of course, that we measure with a gauge, a threaded gauge for the threads, go, no go. And then we have the plain pin gauge that we do to inspect the minor diameter. But one criteria in particular, which is a little bit more difficult to inspect, lots of even manufacturers don't have the right capacity to do that, and that's inspecting the bearing surface of the nut for its perpendicularity to the threads, which is sometimes classified as run out. And so we had some issues with that on a particular flange lock nut. And when we come back, I'll tell you what those issues were and how you can possibly avoid them.
Knowledge is the key to success in the fastener industry, and the Fastener Training Institute has the tools you need to succeed. From advanced to beginners training courses, the Fastener Training Institute provides a wide variety of resources to boost your team's ability to operate at an elite level. Go to fastenertraining.org to see the schedule of online and in-person classes coming up, and reach out with any questions or requests for custom course materials. The Fastener Training Institute, fastenertraining.org.
Well, welcome back to the Fastener Training Minute. This is Carmen Vertullo, and today we're talking about measuring the perpendicularity of the bearing surface of a flange nut to the threads, in particular to the thread pitch diameter, which is the common call out in most standards, inch and metric. We want to know how perpendicular that surface is, the bearing surface, to the threads. And that's important because imagine if the hole in the nut was tapped not straight, crooked, let's say, and you begin to spin that nut down, and instead of that bearing surface hitting flat, one side of the nut hits first. That would not work. You would have all kinds of torque tension issues. You might bend the stud or the nut that the nut is going on. It would damage the surface that you are tightening against and so on. So we want that surface to land all at the same time. And so to do that, we control the perpendicularity of that surface to the pitch diameter. And the way that we measure that sometimes is with an inspection called run out, where we install the nut onto some kind of a thing that can grab it on the pitch diameter. That's normally going to be a thread gauge, but it could be just a threaded stud or something that we can tighten it against. We put that in a fixture where we can rotate it. We put a gauge up against the bearing surface. It's called a run-out gauge, actually. And we rotate that assembly, and we see how much change there is in the position of that gauge from zero, both directions, plus and minus. We call that the total indicator reading or total run-out. And the tolerances on that are not particularly tight. They're relatively manageable. And also, the upside is it's relatively easy to make a nut perfect. When nuts are made, they are tapped in a fixture that holds them very tightly. The tap goes in straight. The bearing surface of the nut is located against the surface, and it's pretty hard to mess that up. So most nuts that I've inspected are pretty much perfect with very little, if any, detectable run out. But every now and then we have an issue. And in this particular case that I've seen 3 times, the issue had to do with lock nuts. In particular, the type of lock nut was a lock nut that was all metal where the nut was pinched or crimped. And in the process of crimping that nut, that bearing surface got deformed ever so slightly. In the case of one nut, which was a relatively large nut, a large metric nut, M22, the crimp was significant and the bearing surface cupped. And we could tell it cupped because when we would put it on a piece of sandpaper and sand that surface, that bearing surface down ever so slightly, we could see the high points and they were exactly opposite of where the crimp was. So that told us that that is what occurred there. Now, the fact of the matter is, chances are in the application, when we tighten this nut down, those two high spots are going to hit first. And as we develop tension or stress on the nut, it's probably going to flatten out and work perfectly fine. However, it doesn't inspect perfectly fine. Matter of fact, it has significant amount of run out. And the typical amount for a nut might be a few thousandths to 8 thousandths or so in the inch world. And that translates into about a tenth of a millimeter, maybe in the metric world. And we have way more than that. And we had a print that we had to follow, and there was just no way around it. And it was very difficult to convince the end user that this nut probably was usable, and we just needed to maybe change the criteria a little bit or do some testing to prove that this particular dimensional nonconformance did not affect the function of the part. So just keep in mind that nut was probably absolutely stunningly perfect up until the point where they crimped it to put the locking feature in. And so we have to be aware when we are buying and manufacturing nuts that have bearing surface perpendicularity or run out requirements. When we crimp that nut, you might lose that feature, dimensional integrity. Well, now you know something about nut bearing surface runout. Not all standards have requirements for bearing surface runout. Not all nut standards do, by the way. Most of them do, but not all of them do. So there may be a get out of jail free card for you, depending on what standard you use. Well, thanks for listening to the Fastener Training Minute. This is Carmen Vertullo coming to you from AIM Testing Laboratory.